Okay, now I'm going to talk about means. So what I'm going to do is I'm going to go through the same process. We're going to look at the same thing. I'm going to show you that, proportions is at the top up here. Now I'm going to jump down here and talk about means. It's right down here at the bottom. And I'll walk through again the notations and the formulas and the checks you have to do. So now again, what I'm going to talk about, I'm going to start talking about the parameter. For means, mu is the true mean. Okay, mu is the true mean. That's the real answer. That's if I went in and I got the weight of every person in the Commonwealth of Virginia, divided it by the total number of people, that would give me mu, the true mean. Not going to know that, so what I'm going to do is what's called an X bar, and that's going to be my sample mean. And that's going to be taking a smaller subset of that group, getting their average, getting an X bar. And what happens now again is this: the mean of all those X bars is going to equal the true mean. Kind of like the mean of all the p hats equals the true p, the mean of all the X bars equals the true mu. And again, this is the random check. So if it states random in the problem, I'm allowed to state that. And again, this is my proof. I can't just say this. I say this because of this. So you're always going to give a reason. The standard deviation is going to be whatever the claimed population standard deviation is divided by the square root of n. And again, on the formula sheet. And again, it's going to be a 10n check. We're going to do 10n less than or equal to big N. This is that independence check. I'm making sure that my sample size isn't too large to violate independence. Now for normal, it's different. It's not 10 successes. It's not 10 failures. It's 2 checks. If the population is stated as normal, I can go ahead and I can say that the sampling distribution is normal. However, if that's not stated, there's only one other check I can do. If n is greater than or equal to 30 by the central limit theorem, I can state that the shape is going to be approximately normal. Okay, so be careful. Proportions, 10 or more successes. Means, you look at the population. If that's normal, your shape of your sampling distribution is normal. If that's not, population is not normal, we need to look at sample size that it's larger than 30. And again, if this is true, what I'm allowed to do is say that we have a normal distribution centered at the true mean with a calculable standard deviation. So that's a 1 sample. So now let's do a 2 sample. 2 sample is going to be 2 samples, and it's going to be, again, a difference. It's always going to be a difference that we're going to deal with. So what's going to happen is it's going to be mu1 minus mu2. We're not going to know that, so we're going to look at the difference between X bar 1 and X bar 2, the samples. And again, we're looking for 0 typically is the magic number. 0 means no difference. If there is a difference, then what we need to do is we can address that concern. So now, the mean of the sampling distribution, so the mean of X bar 1 minus X bar 2 is going to equal mean 1 minus mean 2 if both are random. So we have to check twice. So it's 1 sample check once, 2 samples check twice. The standard deviation is going to be the following formula. It's going to be the first standard deviation divided by its sample size, the second standard deviation divided by its sample size. Again, on your formula sheet, just so you know, formula sheet right here, mean, standard deviation. And again, we're going to check 10n less than or equal to big N for both. And that's, again, our independence check. Our shape, you're going to check 1 and 2 for both. You're going to make sure that sample 1, that population 1 is normal or population 2 is normally distributed. If that's the case, we're good. We move forward. If not, we need to make sure that our sample sizes are sufficiently large, 30 or larger. If that's the case, I can then say that the difference is also approximately normal. And again, our goal in this one is, like I said, don't worry about the Z-score formula. It's to make these distribution normally distributed, centered at a calculable mean with a calculable standard deviation. So that's, again, what we're doing in terms of the process. Again, this is just, we're getting started on this. And now what's going to happen next is I'm going to do an example problem, and hopefully that'll kind of help kind of solidify where we're going on this.